Okay, so this is a question that came out of the textbook, and it'll help us. Do a little of this work about combining vectors or combining forces. So, and I always like drawing pictures of problem. And actually, this problem actually lends itself nicely to drawing picture. So, here we've got a compass rose, and we know a plane is flying on a bearing of 340 degrees. Well, let's see. So 340 degrees on the compass rose looks like this. And we know that speed is 325 miles per hour. And now the tricky part is, actually, let me undo some of this. So maybe I won't be able to, maybe I'll have to erase it. The tricky part is when you're dealing with vectors, and that's all we're really dealing with, is you got to talk about what is vectors always start from the positive x-axis. That's our initial ray when we're dealing with all the trig stuff. So what I'm going to do is I'm going to get rid of that bearing of 340 degrees and think about what's this angle, because that's the angle for the first force here. Well, if it's 340 degrees going this way, that leaves 20 degrees, 340 degrees coming from here. That leaves 20 degrees that's left over. And if you do 90 plus 20, that's 110. This angle is 110 degrees. Let me do some erasing here so we can deal with the wind. And maybe I should do this because this looked like where some people were having a hard time. It's how do you take this direction and a magnitude, a direction and a force, and can break it down into its horizontal and vertical components. Well, if you remember, if we go way back, we can think about this is the reference angle. So if that's 110 degrees, this is going to leave a reference angle of 70 degrees. And over here, the sine's negative and the cosine's negative and the sine's positive. So all we really have to think about, well, let's see, it's going to be the x value, the horizontal part of this airplane's force is going to be, let's see, if you think about it as cosine of 70 degrees equals x over 325. We can think of that as 325 times a cosine of 70. And of course, we know that the x is negative over in that quadrant, so we'd have to stick a negative here. Now, alternatively, what came out in this lesson is that you could just say it's the cosine 325 times the cosine of 110 degrees. And that will, because your calculator knows that if you're taking the cosine of 110 degrees, that's going to be a negative number. We don't have to worry so much about reference angles and things like that. So here, that's the horizontal component of that vector, of that force. Now to get the vertical component is going to be the sine. So it's going to be 325 times the sine of 110 degrees. So that's breaking down that first, the velocity of the airplane into horizontal and vertical components. You always have to have an angle and then the radius, basically. Now they're telling us the wind's blowing at a bearing of 320 degrees at 40 miles an hour. So if we just think about the wind itself, 320 degrees, remember you started due north, and that's 270, so we're somewhere in here. And here's the wind's force. And that wind is blowing at 40 miles an hour. So, mph. So if this is 320, that's going to leave what here? Because this is the angle we really want. So let's see, that's going to be 40 degrees left there plus the 90 before. So that's going to be 130 degrees. So if I wanted to break that down into its horizontal and vertical components, it would be 40, which is the magnitude, the radius, times the cosine of 130 degrees, and then it would be 40 times the sine of 130 degrees. So that's the component force of the wind, and that's the component force of the airplane. Now, it always is good, more pictures, the better off we are, I think. So, but if you think about that tip to tail kind of drawing, what I've got going on here is here's the airplane. And here's the wind. And if I'm going to slide that tip to that tail, so I kind of line those up. And here's that resultant. Well, actually, I probably want to do, I don't know why I went off. Let me try that again. I messed that one up. I want to make parallel lines. I want to make a parallelogram is what I want to do. So let me try this again. Let me try, let's see, can I draw this fairly well? I think so. That's kind of, then this one, then the airplane one's like this. So here's that resultant force. Here's the net force, the net direction. So it's going to be that angle is going to be in quadrant 2, and of course it'll be the magnitude, will have to use that Pythagorean theorem thing with it. So what am I going to do here? So I'm going to add my horizontal and vertical components. So here's the force of the resultant, or the components for the resultants. So 325 times the cosine of 110 plus 40 times the cosine of 130. That'll be the horizontal. And then we do 325 times the sine of 110 plus 40 times the sine of 130. And then at this point, of course, I'm going to pull out my calculator and do some calculating here. Okay, so might as well have you watch me do some things with this calculator. So number one, I'm going to make sure that I'm in degree mode, and I am. I did that by pressing mode. And then I'm going to quit this, and then I'm just going to type in 325 times the cosine of 110. Whoops, 110, Dan, not 100. And then I could either hit equal and then go plus, but I'm just going to do it right here. I'm going to type it right in the way I see it. 40 times the cosine of 130. So that's going to give me a horizontal component for the resultant vector of negative 136 point, let's see, what was it? 0.8. Actually, what I'm going to do is, I think I'm going to just grab this and paste this into the paint program. Let's see, copy. I'm going to come over here. I'm going to paste. We'll move that over here. And then I'll do the same thing with the sine. Actually, I'm going to get really fancy. I don't know if you know how to do this. You do second enter to get what you last entered, or you can do the up arrow and grab it that way with the TIs. It's one nice thing about the TIs. So I'm going to change this to sine and change this to sine. Everything else stays the same. Probably just as fast to type it in, but sine, then I press enter, and that's the vertical component. And let me get copy and paste that. Okay, so if I want to find the magnitude, I just have to, so remember, the reason the Pythagorean theorem works here, because what I've got going on is I've got that red resultant vector, and now I've got the horizontal, I've got the X value and the Y value, the horizontal and the vertical. I can just use Pythagorean theorem because it's the right triangle. So I'm going to square both of those, add them together, and take the square root. I won't bother writing that out. But what I can do is I can come up and grab that number. I'm going to hit the X squared key. Actually, clear. You know what I'm going to do is I'm going to put that in parentheses. So if I just square it as is, it's not going to be a positive number. And then I'm going to square it, and then I'm going to add. I don't have to worry about the 336 being in parentheses because it's already positive. Okay, so that's the a squared, or the x squared plus the y squared, or the horizontal squared plus the vertical squared, and then I'm going to take the square root of that. Remember, raising something to the 1/2 power is the same as taking the square root. So that airplane is flying at 362 miles an hour. Miles per hour. And then I want to get the direction. So that's the actual ground speed. And notice the wind's assisting it. And then I'm going to get the direction, and that's where you're going to use the arctan. So I'm going to come back to my calculator. And I'm going to do second tan of this number. Let's see, where is it? Let's see, that is the horizontal. Nope, I want to do the vertical first because it's y over x, right? So it's that number divided by this negative number. And it's giving me a negative angle. And the reason that happens is what you're going to remember that our work from last semester when we're doing, when you do an arctan, the arctan is defined from, the output is from negative 90 degrees to positive 90 degrees because that's where the vertical asymptotes happen, or negative pi over 2 to positive pi over 2. So if the calculator is telling me this angle here, but I already know that I'm not going to fly at a negative angle if it's on a compass bearing. So really I want to come up with this angle, and then I'm going to convert that to a compass bearing for this problem. Okay, so let me do some erasing here. Whoops, not that. So what I need to do is do the arctan of the y divided by the x. And of course, I've already done that earlier. So actually, I did that, didn't I? So let's see. Yeah. So I know the arctan of that is negative 67.8-ish. So negative 67.8. So degrees. So that's this angle here. And I want to find this angle here. Well, actually, there's a couple things I can do. I'm going to find this angle here. So I know that, and I know that angle here. Let me go to a different color angle. I know this angle here and this angle here are vertical angles, so they'll be equal. So to get this angle that I just did in the new red, I'm going to do 180 minus that, or 180 plus that answer, since it's negative. So 180 plus that answer is 212.2. So this angle here is 212, what did I know, 112.2. But since we want a compass reading, compass bearing, we have to go from here all the way around to here. And there's a couple of ways to do that. I almost think what I want to do is, I know that this angle, I know that the angle between the y-axis, the positive y-axis, and that terminal array, that angle right there that I'm doing in blue, is just going to be 112.2 minus 90. So that angle is 22.2. And since we're going to go all the way from 0, or from true north, which is the old 90 degrees, back to here, I'm just going to take 360 and subtract that. 360 degrees and subtract that. So let's see. Let's subtract 90 from that. Make sure I got my 22 degrees right. And yes, there's a lot of other ways you could do this, folks. Just the way I'm doing it right now. So 360 minus that answer. So it's flying in a direction of 37 degrees. They aren't telling us to do it in degrees, minutes, seconds. So 300, what did I just say? It's 337.8 degrees. At a speed of, what did I say the speed was? 362 miles per hour. Okay, so that's how you do this kind of problem. And when you're dealing with taking a vector and breaking it down into components forms, and that's how, and to add them, that's what you got to do. You got to break it down to the X and the Y, the horizontal and the vertical, put those together, work backwards and get back to your magnitude, your hypotenuse, and then the direction angle, okay? So pay attention to your signs. If when you do the arctangent, and it's a positive number, it's either going to be in quadrant 1. Remember, if you think about that work we did last semester, all seniors take calculus, or all students take calculus, or all seniors turn crazy. All the trig angles or trig ratios are positive in quadrant 1. Only the sine and cosecant are positive in 2. Tangent, cotangent, and cosine and secant. So since we're dealing with tangent and arctangent, if we get a negative angle, you know you're dealing with something down here in quadrant 3. We got to make sure you subtract it and get that angle here. If it's a positive angle, then you're probably working in quadrant 1. Okay. Not to say we won't end up in quadrant 3 sometimes, but you got to pay it. That's why the sketch of the angles help. Okay, hopefully this helps you do this.